We're driving east on the original Lincoln Highway, through the valley between the Tuscarora Mountains and South Mountain, which is the final slump of Pennsylvania's rolling Appalachians, towards Gettysburg, Pennsylvania, where the bloodiest battle of the Civil War was fought, and the course of American history was profoundly influenced by geologic features dating back to the Triassic and Jurassic. If you happen to have a geologic map of Pennsylvania handy, you can see these elongate belts of folded and faulted marine sedimentary rocks. Gettysburg is just to the east of the easternmost extent of the Pennsylvania Appalachians, which formed predominantly during the Alleghanian orogeny some 300 million years ago. To begin, we're looking west, towards the mountain pass we just drove through, which is the same route General Robert E. Lee's Confederate Army took when headed this way in early 1863, after several conflicts in eastern Virginia. Shielded by the Blue Ridge South Mountain Barrier, they had no way of knowing they were about to come in contact with the Union Army of the Potomac under General Meade. In short, the meeting of the two armies in Gettysburg was largely a coincidence. After driving further east towards Gettysburg proper, we're standing on top of McPherson Ridge, which is very windy, hence the voiceover. It, along with her ridge to the west, behind us, are resistant sandstone ridges of the Gettysburg Formation, which formed approximately 180 million years ago with the opening of a rift basin during the late Triassic. These sedimentary lowlands are broken up by hills and ridges, which formed when a dense 2,000-foot slab of igneous rock called the Gettysburg Sill and two 50-foot diabase dikes were thrust into the Gettysburg Formation. On July 1, 1863, Union troops encountered Confederate scouts just below McPherson Ridge, which is where we're going now to see what kind of terrain they were dealing with. These low-lying, north-south oriented sedimentary ridges, along with the railroad cut here, which was unfinished at the time, provided shelter for Confederate soldiers as the Union troops were retreating back towards Gettysburg. This early Mesozoic sedimentary bedrock was deposited in the Gettysburg Rift Basin, which opened up initially with the breakup of Pangaea in the Triassic. These are tilted sandstones, mudstones, and shales, but what we're looking at right here specifically is a red shale. And these sorts of outcrops underlie much of the battlefield, but they aren't really exposed as well nearby. Those Union troops retreating back towards Gettysburg crossed the open expanse of what would become the battlefield, planning to overtake what I'm standing on top of right here, this comparatively towering 18-meter-tall ridge to the east of town, formed by the broad Gettysburg Sill overlain by weathering-resistant York Haven diabase. This would become the Union stronghold of Cemetery Ridge, which was much wider and taller than Seminary Ridge, which is where the Confederates wound up. We're standing here on top of the ridge, which is one of those thinner north-south oriented diabase dikes cutting through the Gettysburg Basin that we saw in the diagram earlier. These elevated dikes are dense and very resistant to weathering, and their fine-grained composition, which you can see here, suggests rapid cooling with intrusion. Diabase was very important to the outcome of the battle because it's this hard, homogeneous rock which weathers slowly and only breaks apart into these big boulders. The soil also wasn't useful for crops, and so you had this big exposed field the Confederates were trying to advance through with these scattered diabase boulders. Shown here, approaching the Union line on Little Round Top, you can see they provided some cover, but also broke up lines of advancing soldiers. We're now ascending Little Round Top, one of the highest points of the Union stronghold on Cemetery Ridge. By July 2nd, they had this very advantageous spot completely secured, and July 3rd became a decisive day. Pickett's men led the charge across the basin of Triassic shales and sandstone making up the Gettysburg Formation, which separated their hold on Seminary Ridge from the Union hold on Cemetery Ridge. As you're about to see, the terrain they had to cross, made up of the sediments of the Gettysburg Basin, weren't as flat as they appeared. Along the edges of the intrusive sills and dikes, the red mudstone we saw earlier was baked to form hornfells, which were tectonically tilted along with surrounding sediments to form a gently rising slope towards the diabase outcrops on which the Union soldiers had so advantageously positioned themselves. This made the advancing Confederate troops easy targets. The thin soil on the sides and tops of these hills also made it almost impossible for both sides to entrench themselves. Since they were unable to dig and create artificial barriers as they normally would, they had to rely on existing outcrops and scattered boulders for protection, like these Gettysburg Sill outcrops here, which lie between Seminary and Cemetery Ridges. But these sedimentary lowlands are more than just a graveyard for Confederate troops. They're also a graveyard for dinosaurs. This bridge covers the small Plum Run Creek, which flows beneath Little Round Top, where we just left, to Devil's Den, our next and final stop. The Triassic sedimentary rocks on the battlefield are mostly unfossiliferous, but those used to build this bridge were quarried from the same formation nearby and preserve several dinosaur footprints. This guy was apparently a heterodontosaur, and nearby we have a couple of Triassic hindprint fossils from two species of coelosaurs. I wanted to finish up with Devil's Den because although its boulders provided many important hiding places for Confederate soldiers during their attack on the Union line, this was mostly a sniper hangout. This is also one of the best outcrops of that diabase that turned out to be so important to the outcome of the battle. These rocks are mostly fine-grained, dark gray to mottled gray and white, and are made up of clastic plagioclase, or black pyroxene and augite. Though in most places the texture is obscured by moss and lichen, you can see some pretty cool permafrost wedging here. Unfortunately, you aren't allowed to take a rock hammer to the landmarks of a national military park. I'd like to thank my dad, as well as Stan Lee, the geology dog. Thanks for watching. Don't forget to like, comment, subscribe.